Good morning, this is Mr. Morales, and this is probably my third attempt at this video because we just got back from the break, and like everybody else, I'm a little spaced out still. So today we began reviewing quadratic graphs, quadratic equations, and more specifically their graphs today for this video. Now, beginning with some basic ideas and definitions. First, we have what are quadratic roots. So the points you get at when you make the graph, which is a parabola, wherever it intersects the x-axis, that is what we call a quadratic root. We also have multiple names for these things because like in everything else in algebra, we'll have multiple names depending on how you're referring or using the mathematics to talk about the same exact thing. So along with the word the root or roots, quadratic roots, they'll also be called the zeros, the solutions, and the x-intercepts. Now, what do these look like? So here in the middle of our notes, we have number of solutions. Typically, you have your parabola, which is your standard horseshoe-shaped graph that we see here, and it'll intersect. Whoops, I didn't mean to move it like that. There we go. It'll intersect your graph at the x-axis in two spots typically, and those are your two solutions. But it's not uncommon to have a parabola that maybe only intercepts or makes contact with your x-axis in one spot. And when that happens, then it's considered to have only one solution. And you can also have no solution. It is possible to have a quadratic equation whose parabola, when you graph it, is maybe not even anywhere on an x-axis intersection, and therefore you would have no solution. So those are the three types you can get. Now, today we're going to focus on making the graphs. So what we're going to do is we have a couple of examples, and we're asked to find the solutions of the following quadratic equations by graphing. So the first thing I want to do is I want to find the axis of symmetry, because if you remember from before we went on break, which I'm sure most people don't, the axis of symmetry gives you also your x-coordinate for the vertex. So here we have three equations in standard form. Remember, we have A, B, and C. A is the number of x squares that you have. B is the number of x's that you have, in this case positive 4, and C is your constant at the end, negative 5. To get your axis of symmetry, that is negative b over 2 times your a value. So if I substitute in all my values here, I get negative 4 over 2 times 1. Or in other words, negative 4, there we go, negative 4 divided by 2, which gives me a negative 2. So that's going to be my vertex x-coordinate, negative 2. Now all I have to do is use my calculator and plug in negative 2 into this equation. So I want to get what does my y value equal when I have negative 2 squared plus 4 times negative 2 minus 5. So I substituted all the x values with that, and I get a y value of y equals negative 9. Now I have my vertex. So it appears to be that since my graph is positive 1, it's going to open upwards. So it's going to go to the left and to the right. So I'm going to pick some numbers to the left and to the right of my vertex. So I'll pick, let's say, negative 3, negative 4, negative 5, and then I'll go to the other direction, negative 1, 0, and then 1. I'll plug each of these x values into this equation here to get each of the y values that go with it. When I do that, I get the following values. It would be a little too long to show you guys how to get each and every single one. And so you guys should know how to do this already. I'll go ahead and now I'll plot my points. I know my vertex, which is right here, is at negative 2, negative 9. So that's going to be right there. And then I have my two y-intercepts at 1, 0. So here's the right side of my parabola. And my far left side one's at negative 5, 0, 1, 2, 3, 4, 5. And then I have all the points in between. I have a point at 0, negative 5. There's my y-intercept, 1, 2, 3, 4, 5. That helps my parabola a little better. Negative 1, 8. Negative 1, 8 right here. And since my line of symmetry goes to the vertex, whatever happens on the right side of my graph happens on the left side. So I just use this like a mirror. Since this point's 2 squares to the right, this one's 2 squares to the left. And I have a nice perfect mirror image. I can get my parabola graph. Nice and neat. So I could say that the solutions, which are the x-intercepts, are at, now here we use bracket notation, they are at when x equals -5, we have a solution, and when x equals +1 down here, we have a solution, or a root, or a 0, or whatever you want to call it. So let's go ahead and move on to the next example. So going on to number 2, let's go ahead and practice this again. So I'm going to go ahead and find my coefficients. A is a +1 x squared, so it's opening upwards. B is a -2, and C is a +1. Axis of symmetry will go through -b over 2a, x values. So -b, if it's a -2 and I have a negative sign in front, that makes it a +2 over 2 times 1. 2 over 2 gives me a +1. So +1 is my vertex. I'll put that right here in the middle. Now I'll go ahead and just plug in 1 for x to solve to get my y variable for the vertex. And when I do all that, I get y equals 0. I'll pass this out. So there is my vertex at 1, 0, right there. Now I go ahead and pick some points going to the left and going to the right. When I plug them into the calculator and solve for all my values, I get the following y values. If you notice, because this is my vertex, I get mirror image values for y's. I get a 1 and a 1, a 4 and a 4, a 9 and a 9, because the numbers are also evenly spaced apart. Just a little trick to help you graph these a little faster. So 0, 1 is my y-intercept. Remember, this is my axis of symmetry. This is my mirror. So if I have a point 1 squared to the left of that line of symmetry, and I have a matching point 1 squared to the right of it, which is right there. -1, 4. It's -1, 1, 2, 3, 4. It's right here. 1, 2, there we go. It's off a little bit. You figure out what's going on there. This point is 2 squares away to the left, so that matching point will be 2 squares to the right. And then my third point is -2, 9. -2 up here, -9. This point is 1, 2, 3 square, or 3 jumps away units from my line of symmetry, so the opposite point will be on the, well, 3 squares to the right of that. And there's my parabola. Or you can just graph each point one at a time to your heart's delight. So where are my y-intercepts here? Well, I only have one. There's only one solution in this case. So not my y-intercept, I'm saying that's the wrong term. My x-intercept, my roots in this case, is only one root, and that would be at +1. Now let's go ahead and practice again. That way I'll be a little warmed up too for actual class today when I present this formally. All right, number 3, same thing again. So here, let's go ahead and get our coefficients. A is -1 because I have 1x squared. B is +2 for the 2 x's. And C is my constant at the end, -3. My axis of symmetry is given through the equation -b over 2 times a. So I'm going to have a -2 over 2 times -1, which effectively gives me -2 divided by -2, or in this case, a +1. I'll throw that kind of just right in the middle. I'm going to go ahead and solve for the y by putting in a +1 everywhere that I see an x in the above equation. And when I solve it, I get a value of -2. So a +1, -2 is my vertex. +1, -2 right there. Now since my a value is a -1 over here, it's going to go downwards. So I should be expecting that. I'm going to go ahead and plug in numbers to the left of +1 and to the right. When I plug in those numbers into my equation, into my calculator, I got these respective y values. I can just graph each one. -2, 11, and -4, 11 won't fit on this graph, so I'll go ahead and just leave those out. Oops, I didn't mean to make a mark with my notes over here. There we go. Continuing, -1, -6, -1, 1, 2, 3, 4, 5, 6, right there. So that'll have a matching point over here. And then, let's see, I got those two. 0, -3. There's my y-intercept. So I have a matching point over here on the other side of my vertex. Alright, so if I go ahead and graph what I can graph, are my x-intercepts? Well, if I want to formally write this, if I must insist on having a bracket, I can say x then is just going to be an empty bracket because there is no solution. Or in other words, I just put the 0 with a slash to it. There's no solution. So the rest of your notes continues on with more of the same, with 4, 5, and 6 on the back being the same exact thing. You can go ahead and do those on your own and then ask your teacher to check them. I want to get to the bottom part on the back of my notes, which is the first big idea of this review, which is the idea of the discriminant. The discriminant is a formula that tells you how many solutions you can expect just by using the A, the B, and the C's and manipulating them. So the actual equation for the discriminant. Now, first of all, you have to have your equation in standard form. That means with ax squared, and then you have x's, and then you have your constant. So in that exact order. And y is on the very other end. In order to use it, the equation is going to be your b squared minus 4. My bad, I had to pause it there for a second. The bell started ringing. So we have b squared minus 4 times a times c value. Now you have to know your a, your b, and your c in order to use it. Here's how it works. When you plug it in and you get an answer, you're going to get one of 3 kinds of answers. The number is not as important as the actual value of the number. So here's what the notes talk to us about. If your discriminant is greater than 0, then there are going to be 2 solutions. That means your parabola will hit the x-axis in 2 places, either going upwards or going downwards. If you use the discriminant formula and you get an answer equal to 0, that means your parabola is only going to have 1 solution. It's going to only touch the x-axis at the vertex in 1 spot. Now, if you get a discriminant value that's a negative number, then that means you're going to have no solutions, or 0. You have one of those floating parabolas that never makes contact with the x-axis. So let's go ahead and practice how the discriminant is used in some examples below. So for number 7, our a value is the 1 for 1x squared, our b is the 5 for 5x, and our c is positive 4. b squared is going to be 5 squared minus 4 times our a value, which is 1, times our c value, which is 4. So when I do that math, either in my calculator or manually, I get 25 minus 4 times 4, which is 16, to give me an answer of positive 9. According to my notes, a positive or an discriminant that's greater than 0 means I'm going to have 2 solutions. So this parabola will hit going upwards in the x-axis in 2 spots. Number 8, my a value is 1 for positive 1x squared, my b value is a negative 3, and my c value is a 10. If I use the discriminant formula, it's going to be b squared, which is negative 3 squared minus 4 times positive 1 times 10. Negative 3 squared is negative 3 times negative 3, which is positive 9, minus 4 times 10, which is 40. That's going to give me a negative 31. A negative or discriminant that's less than 0 means I'm going to have 0 solutions. So this problem is going to be one of those floating ones. Going on to number 9, excuse me, being a little cotton mouth there. Going on to number 9, 10, 11, 12. Number 9. So A is positive 1, B is positive 10, and C is 25. So let's go ahead and use the discriminant. B squared will be 10 squared minus 4 times 1 times 25. I'm going to get 100 on the left side. 4 times 25 is also 100, so 100 minus 100 is 0, which means I'm going to have only 1 solution. Don't get confused with that. A 0 in the discriminant doesn't mean you're going to have 0 solutions. It means it's only going to have 1. Your problem is only going to touch the x-axis at the vertex at 1 spot only. It only has 1 vertex. Number 10, my a value is positive 2, my b value is negative 4, my c value is negative 3. Discriminant time, it's going to be negative 4 squared minus 4 times 2 times negative 3. On the left side, when I do it, I get 16, and then I get negative 4 times positive 2, which is negative 8 times negative 3 is positive 24. So that's going to equal a positive 40, which means I'm going to have 2 solutions. Going on. Number 11. My A value is 4, my B value is negative 12, and my C value is 9. If I use a discriminant, it's going to be negative 12 squared minus 4 times 4 times 9. We get 144 minus 144, which again gives me a 0. If the discriminant is equal to 0, then there is only one solution. And finally, number 12. My A value is going to be negative 3, my B value is positive 5, and my C value is negative 8. B squared minus 4AC, which is my formula, it's going to give me 5 squared minus 4 times negative 3 times negative 8. I'll get 25 minus 96. Already it's going to be a negative 71. A negative number means no solutions. So there's your quick and very rough example on how to apply the discriminant and how to graph basic quadratic equations. I hope this helps you with these notes. Best of luck.